once you have an ER diagram, you can convert from the ER diagram, you can generate all the tables. So it's, start with the strong entities. So in this particular example, those are faculty, course, and book. So we have okay. So we have the three strong entities. So the next thing is to look at the weak entities section. So we have so if you recall, in order for a weak entity to get a key, you have to connect it to its the strong entity that it's connected to via the box or the triangle, or what's it called? It's not a triangle. It's a square, double line square. So you have to connect it via that. So then take the primary key from course. So we have okay, so at this point, we are done with the strong and the weak entities. So the next thing you look at are the relationships. So we first start with a 1:1 relationship, but none of the relationships here are 1:1. You have 1:4, m:(n), 1:5. And of course, we've already handled this through the weak entity rule. So we don't have to look at that one right now. So we don't have any 1:1. So the next thing to do is to look at 1:n relationships, and pretty much this one and this. So both of these are 1:n relationships. So then you look at the, you have to add the primary key. So when you look at this relationship, the course is the one that's on the n side. So you have to add the primary key from here into course. So we have which one is I looking at? FNO. So you add that as a foreign key in course. And similarly, when I look at this one, you have to add the primary key of C number into book. So we have as a foreign key. Okay, so that's all with the 1:n. And then finally, we look at the m:(n) relationship. So that's the last one. So we're going to look at and there you add the primary key from faculty and the primary key from book number. And that's all there is. So we have that as the key. So these are the tables that are generated from this example. Does anyone have any question? Did you understand what I just did? Okay, so there are other things. I mean, you can just play around with this example. So you could check, suppose instead of doing this as a 0:m relationship, suppose I changed it to 0:1. If I made that change, how does that change the tables? Does it make any, is there, would it change the tables in any way? So this you can try on your own. If you make from a 0 to m, if you made this a 0:1, yes, it will definitely change things, because if you made it a 0:1 out here, then this becomes a 1:n relationship. So the moment it becomes a 1:n relationship, you have to remove this adobs table, will not be there any longer. And instead you would have to add, so yeah, so if it's a 0:1, you would not have this, and instead you would have to add to book, you would have to add one more field, F number. So so that's the change that would happen. And then there are other questions, for example, I could ask a question. If you're told, like if you're given that if there are, say, 3 rows in faculty table, how many rows? So basically I'm saying there are 3 faculty members. So how many courses would there be? What's the maximum number of courses? That would be the. And you can come up with a whole bunch of other questions, on the similar line. So an ER diagram is very, very powerful. It really conveys a lot of information. Not only does it tell you what kind of tables you are generating, but it also, in fact, will give you a limit, a min and a max count of the number of entries you can have in the tables too. So an ER table, even though it looks really simple and it's all graphical, is actually a very powerful tool for a database designer. So does anyone have any questions? So I have put up the last assignment. I haven't really posted it so much, but I put it in the files folder on my courses. And so it's got a bunch of questions on ER diagrams. So it's a good thing to look through it, because even though when you sit in a lecture, it all, I mean, either you understand it or you don't understand it. But either ways, an assignment is a good way for you to really understand the material, whether you understand it in the lecture or not. So if there are no questions, I'm going to move on to the next topic, which is constraints. So we are going back to SQL now. So really, we are going back to SQL, but now we are returning to the DDL, the data definition language. So in the textbook, it's all over the place. So in the new edition, it is in sections 5.2, 5.3, 6.1, 6.2, 6.4, 7.2, and 7.4. So because constraints are just, they mention it in bits and pieces all over the place. So I just want to put them down. And if you have the old edition, it would be in 3.2, 3.3, 4.1, 4.2, 4.4, 5.2, and 5.4. So it's just pretty much, they move the chapters around, but it's the same thing. So constraints are, like sometimes, like if you say things like, for example, if there is a constraint that states that all department numbers must be greater than 10 and less than 100. So that's a constraint. And you don't want there to be data entry errors, and you don't want programmers to have to deal with that in their, when they write their application programs. So this is something that you want defined in your database in the DDL part of the data definition language. And so far, we haven't really done how it's explained in the, how do you define them in the data definition language? So that's what constraints are about. So they are part of DDL, and these constraints are written once in the schema DDL. And they're stored in the database. And every time you change the database in any manner, if every time you add data or delete data or you update the database, these constraints are run. And then if you violate the constraints, you will get some warning. So they are executed. I just want to make sure I'm recording this. Okay, good. Sometimes I forget about recording. So execution so either at bulk loading, like, if you're like, when we start our labs, you kind of load a bunch of data in. So these constraints are executed at bulk loading. And every time you insert, delete, or update the database. So they're also called integrity constraints. So there are different types of integrity constraints. So we have and some of these you've seen before. For example, you have seen key constraints. If you say if it's a primary key and all, so a social security number is a primary key, and you try to insert a second employee with the same social security number, that's a constraint. So there are the key constraints. So and so you have the primary key constraints. You have also the candidate keys when you say unique and non-null. Those are candidate keys. You have the primary key constraints. So those are the key constraints. Then you have foreign key constraints. And we'll talk a little more about foreign key constraints today. Sometimes they're called referential constraints. So in addition to these constraints, there are also certain attributes. Those are not necessarily key attributes, but you do not want them to have null values. So you can, when you state that something has to be non-null, it'll ensure that you always enter some value for it. Then you have other constraints such as attribute-based constraints. And I'll talk about them too. Tuple-based and interrelation. Now, these are really powerful constraints, and I will do examples of them, but unfortunately, they are not available in MySQL, which is what you're using. But if you try most other databases, Oracle or SQLite and all, many of those databases, they do have some or all of these other type of constraints, but unfortunately, they're not in MySQL. So you won't be able to test these three constraints in MySQL. The rest you'll be able to do. Okay, so let's start with the ones that are available in SQL. So let me So now I want to zoom in to the DDLs that we have seen in labs. I mean, I've uploaded, and even though none of your assignments dealt with the DDL parts, in order to create the database and have it in your account, you had to upload and run the stuff that I had uploaded on my courses. So you've seen some of the stuff. So create tables, for example. So we're going to look at those SQL files that I had uploaded on my courses for you to get started. So let's look at the create table. So we have DNO integer, and then you say dname string. And then if you write non-null, so that will ensure that every value in that attribute, I mean, every row with dname must have some value in there for dname. Okay, then we have all these statements which states that primary key, DNO, unique, dname. Okay, so unique dname, so that all that signifies is that this is a candidate key, while D number is the primary key. And whenever you have a primary key, that also implies that it has to be unique and non-null. So that goes without saying, that primary keys have to be unique and they have to be non-null. You can't leave it empty. And then if you look, I mean, we also have this line about the foreign key. So we state foreign. So when we did ER diagrams, you understood what foreign keys are. So, and now, but you have to state them explicitly in your DDL. So foreign key references, employee. So now it gives you the table where it is, and it tells you which attribute in the employee table. So if you look in the department table, it'll go somewhat like this. And so now you understand what this foreign key means. And then I'm going to show you also what it means in terms of constraints too, because the moment you state that something is a foreign key, there are certain constraints that will get enforced automatically. And so one of the things for MySQL is that all the foreign keys, they must always reference the primary key of the other table. It cannot be a candidate key. It has to be a primary key. Some of the other databases like Oracle and all may allow you to have foreign keys that reference candidate keys and not primary keys, but MySQL, it has to be a primary key. So the meaning of a foreign key, this is what it actually means. If you wrote it down in math, or it means that if X is an element of department dot MG manager social security number. So what this means is if X is a manager social security number that is in department, that's what it really means. That will imply that X has to be an element of employee .ssn. So that is the meaning of a foreign key constraint. So it is very easy to violate the foreign key. So I'm going to show you some of the possible violations that you can have. So some of the possible violations you could have is you might try to insert into department a Y that is not an element of employee dot social security number. So if you try to write down a social security number in department that is not there in the employee table, it will give you an error. In fact, it won't allow you to do that. You could try that out in MySQL. So that's, I do want to mention, I think I mentioned earlier that the last assignment is on ER. I won't really be giving you any assignments on things like constraints and triggers and stuff. And you can see why. I mean, these are really like labs that you need to try out on your own. So you have the company table, try out some of these things. I mean, even though when I'm talking about it, it looks really simple and you think you understand, it's really when you try out some of the stuff that you really will get it. So you should try inserting into department something that does not, it's not an employee's table and it'll give you an error. Then there are other errors too. So for example, if you try to delete from employee. So if you look at all the DDL, files, the SQL files I gave you to start up the company database, I always delete employee table last. The reason is if I try to delete the employee table first, it won't get deleted because there are all these foreign keys that are pointing, there are from pretty much every table, there's a pointer to the employee table. So if you try to delete the employee table, what will happen? You'll have, for example, I deleted the employee table, then in the department table, I have all these managers' social security numbers in there. So that would be a problem. So I cannot delete the employee table unless I've deleted all the other tables that point to the employee table. Then if I try to update employee.ssn, and that makes sense too, because if I try to update, suppose suppose 1234 employee 1234 is the manager in the department table, and then I remove employee 1234, update that the social security number in the original table, that would give me again an error. So all of these are automatically checked by the database. You don't have to, a programmer does not have to do anything. And the last type of violation is if I try to update department.ssn. Oh, department.manager.ssn. Again, for obvious reasons, if I updated it to some manager that does not exist in the employee table. So these are all the foreign key violations that are automatically taken care of the moment you put the statement in your DDL. So it's really, really good because as a programmer, you don't have to worry about dealing with these violations. Can you imagine if you were doing this in a program, all these checks you would have to do. So now you don't have to do it. Your program's a lot cleaner because you don't have to do all these checks in your program. So, by default, now if you tried in your company database, if you try to do any of these actions, it will give you an error. It won't change the database. All you'll get is an error. But you can change the default action. So I'm going to show you how you can change it and what are the other actions you could do. So I'm going to do it it's the department table example. It's a lot easier to explain this with example. So let's look at the department table. And let's say we want to insert in the department table, or we want to update the department table. So the default action is always to restrict. So what that really means is that this action is not allowed. So it's going to give you an error message. So this is the default. So you don't have to mention action restrict. If you mention nothing at all, which is, it is not going to allow you to do any kind of violations, because the default is always restrict. But there are other things you could do. But the other things that you could do are not in the department table. In the department, the things that you could do are really about all. Okay, I think it's easier for me to just explain this with the example. I can't, so let me just continue with this. So let's look at the primary, the employee table, because the foreign key manager social security number is referencing the employee table. So let's look at the employee table. And primary key is SSN. That's the one that the foreign key is referencing. So the actions are delete and update. So in the employee table, when you delete and update, these are the possible actions that you can take. So the first one is the same thing, restrict, that we had for the department table, which is the default. But there are two other possibilities. The second one is set null. And the third one is cascade. So what happens is that in the department table, if you do any kind of violations, any kind of insert or update table, you have the only default action is restrict. It will never allow you to insert a manager's social security number that does not exist. It will never allow you to update to a manager's social security number that does not exist. So that's in the department table. But the employee table is a different matter altogether. It is possible in the employee table to delete an employee. So for example, let's say John is a manager and John's social security number is 1234. It is possible for me to delete John from the employee table and not have an error message. And it is possible if I do either of these two options. And since we're running out of time, I will continue with this in the next class, which is not on Friday, because we already had a class on Friday. I mean, that was on yesterday. I don't know why UNH has that weird thing, but I guess it was only there this semester because of